causes a tornado? Well, I can tell you research meteorologists far more brilliant than I could ever hope to be spend their entire careers trying to answer that question definitively. So here is a humble, simple answer. First, you have to have cold air aloft. You have to have a lifting mechanism. You need warm air at the surface that's going to want to rise all by itself, and you need two kinds of shear, horizontal and vertical. Let's, for the moment, just deal with vertical shear. We have an upper level low pressure system. It's causing winds to move to the north in some cases, but it's in other cases sending winds to the east. Now that encourages air to rise from the surface, which is the development of our updraft. You go to the surface, you will find, in this case, very moisture-rich air coming in off the Gulf of Mexico straight from the south. South winds at the surface. But at the top of the atmosphere, we still have those west winds along. They're going to come along and take our updraft. They're going to tilt it, and that is the beginning of a very strong rotation. A powerful storm is taking shape now. Let's put that all together. We're going back to the upper levels of the atmosphere. Here is our upper level low pressure area. Remember, we have that upper level divergence, encouraging the air to rise. But this is such a large system, it's controlling the weather at the surface, bringing in very dry air, which is a forcing mechanism all of its own. It's going to force this warm air. Buoyant, it wants to rise all by itself anyway, to rise even more. And when it starts to rise, we're going to find that the updraft develops and finds these west winds aloft. But before that happens, just this change in wind direction, surface winds out of the south, west winds above the surface, will cause the surface winds to want to rotate. That's a horizontal rotation we call a horizontal vortex. Once that gets going, when our updraft starts to develop, it's going to be carried, this rotation, into the updraft, so it's going to want to spin. Now, for a moment, let's just take away these west winds aloft. What will happen in this case is that the storm will become top-heavy with cold air, collapse, and kill it. But add those west winds, they come along and they shear off the top of this storm, and we get our anvil. Now the downdraft comes all the way to the surface without killing the updraft, and more importantly, the updraft is left free to rotate. As it pushes toward the surface, the first thing we see at the base of the cloud is a wall cloud, then we see a funnel cloud, and when this circulation reaches all the way to the surface and touches it, that is when we have our tornado. Cindy?